Okay. So howdy, my name is Xingjian.
And I'm Max Griffith.
Okay, so like this is our presentation for the final project of Ethan 314, and the name of our project is called Merkle Tree Encryption System. So our project is like a system to encode and decode with the Merkle tree, and if you choose encode, it will reading from a file, mostly a text file, and it will reading and then store them as a array list, and then build up a Merkle tree on it. And after that, it will store the root hash of the Merkle tree, and then shuffle the order of the messages. Then it will print all of this stuff into an output file, and then you can use the output file as an encoded file. And for decoding part, you can just reading the decoding file with our system, and it will recognize the first one as the hash code, and the rest of the file will be the disordered messages, and then it will use the permutation to calculate for all the possibilities, and then test all the possibilities by making a tree upon those orders. Once they found two matched root hashes, which means this order is the correct order from the original version, then we know what is the right order for this message, and then we can output in file. So Maxwell start talking on the data structure about our project. Okay, you can share right now.
Mm-hmm. Okay, so I'm going to go over a little bit of the Merkle tree here. So to create our Merkle tree, we start with all the messages that we're going to need. And so once we create the Merkle tree, we put in the messages, and that's going to go into this const function down here. And the const function is going to take all the parent values, and it's going to merge them all together. So it's going to take these two nodes, which is going to be datasig get I and get I plus 1. It's going to merge them together. It's going to put them to a new list. And then the datasig size mod2 equals 1 is going to be if it's just a lone node. So there's 2, 2, 2, 1. So this is for the 1. But it keeps merging up these two files, or these two nodes every time, and it recurses it with itself. So it basically gets smaller and smaller and smaller until you end up getting the root node. And so here I have the parent right here is return datasig.get 0.50. The size is 1, which means we found the root node. So I'm also going to go a little bit over the node and the leaf. So our node is going to be our parent class, and it's an abstract class. And it has an abstract method here with the toShe method. And then leaf and non-leaf are going to be the two inherited classes. So node is going to give a non-leaf parent to leaf and non-leaf, just so we can be able to transverse off the list. And so now I'm going to give this back to Xingjian so he can we can show our presentation.
Okay, so back to our driver. So the driver is divided by two parts. We basically have the part of encoding and the part of decoding. So for the encoding part, I talked in the intro. So the encoding part, it will just reading from the file, and then reading from the file, and then build a tree upon that. Okay, so right now I use the collections to call the shuffle function, because shuffle function is not just for the array list. It's also for all kinds of the data structures. So that's why I use collections here and get the root hash. And after that, it will store everything in output file, like the root hash and the disordered messages. And for decoding part, we first we ask for which of the file want to be decoded, and then we can read in the file and recognize which one is the root hash, which one are the disordered messages, and then we call the permutation and to calculate for all the possibility about the arrangement of these messages, and which are the all kind of orders. Then we test for all these orders by just testing them for different order of the messages, and then we calculate for the root hash. If those root hash are matched, then we can just jump out from the loop, and then we know we got what we want for the order of the messages. And then we can put them into an output file And after that, you can see them in the output file called decoded.txt. So, but now I will run our program to show it really works. So before I run it, I want to show like here is our local directory, the src folder, and we have like a message.txt as an example about our about our messages to be encoded. It's basically like 7 short sentence phrases to be encoded. So right now I will run it, and okay, you got it here. So first I want to encode this, and then I need to type in the name I want to encode. So I type message.txt, and then the system shows like, okay, encoding is finished. So let's go to our directory. So here you can see like the encoded text is where we store all the encoded messages. So you can see like the sentence is in this order. Then we have our root hash. And then we want to use it to decode. And the result will be stored in the decode.txt. As you can see, it's empty right now. So I'll run it again. Okay, this time I want to decode. And I need to type in the name, which is encoded.txt. And you can see encoding is done. So then we go to check it. Decode it here. And we'll compare with the message. And you can see all the same. So I think that's it for our presentation about our final project. As you can see, it used the Merkle tree to encode and decode our messages and use the permutation to calculate for the right order. And our coding actually followed the coding standard, which we have the introduction for all the files, and also for all the functions we have, and I have some like more comments to make it more readable. And that's it for our presentation. Thank you.